Hello everyone and welcome back to the FooTech HD channel. Building a jumbo jet engine is a remarkable feat of precision engineering. From the moment the project starts until the engine is dispatched, it takes approximately 20 days. This massive machine generates 75% of the engine's thrust, propelling about 1.2 tons of air per second when at full throttle. The process involves thousands of components carefully assembled by skilled workers. The main assembly plant for Rolls-Royce jet engines is located in Derby, UK. This vast complex covers 300 acres and has been the heart of Rolls-Royce operations for a century. The city of Derby has a deep connection with the company, with many of its residents either working for or being connected to Rolls-Royce in some way. Rolls-Royce's heritage lies in aircraft engines, and today, they are known for their pioneering family of Trent jet engines. These engines power various wide-bodied airliners, including the Boeing 777 and Airbus A380. One of their most successful engines is the Trent 700, which has accumulated over 13 million flying hours and is used in the Airbus A330. The assembly process of a Trent engine is a complex and meticulous task. Each engine is built from modules, and each module is made up of thousands of components. The production line must deliver a new engine every 36 hours to meet the high demand. The fan blade is a critical component of the engine, providing 75% of its thrust. It is made from high-grade titanium, transformed into a unique design. The blade is hollow, which contributes to the engine's superior performance. Rolls-Royce's innovative manufacturing processes enable them to create these intricate fan blades. Throughout the entire assembly process, strict quality control and testing measures are in place. Rolls-Royce runs thousands of hours of testing to ensure the engines meet the highest standards of safety and efficiency. Any defect can lead to catastrophic failure, so precision and attention to detail are paramount. The competition in the jet engine industry is fierce, with General Electric being one of the major competitors. Rolls-Royce continuously strives to improve its designs and technologies to stay ahead in the market. Rolls-Royce's success is not limited to building engines for commercial airliners. They are also involved in powering helicopters, business jets, military aircraft, and even naval vessels. Their engines have a proven track record in powering some of the world's most iconic aircraft, including the Concorde. In recent years, Rolls-Royce has been focusing on creating more fuel-efficient engines to support the aviation industry's push towards sustainability. Their Trent engines, particularly the Trent 1000 for the Boeing 787 Dreamliner, have been designed with fuel efficiency in mind. Materials research and innovation. The pursuit of optimal materials is central to the success of a jet engine. The Materials Research Laboratory at Rolls-Royce is a hub of scientific exploration and innovation. Material scientists are tasked with developing new alloys that can endure the harsh conditions within the engine's core. These materials must withstand extreme temperatures, corrosive environments, and mechanical stresses, all while delivering peak performance. To achieve this, the scientists work with a multitude of alloys, experimenting with various combinations of elements like nickel, titanium, and cobalt. The goal is to create alloys with exceptional mechanical properties and high temperature capabilities. The research extends beyond the laboratory, with teams globally collaborating and drawing on expertise from academic institutions and research centers. Blade casting. A closely guarded secret. The turbine blades are the workhorses of a jet engine, tasked with extracting power from the hot, high-pressure gases. Rolls-Royce's turbine blades are unique due to their monocrystalline structure, achieved through a closely guarded casting process. Monocrystalline blades have a single crystal structure, which eliminates grain boundaries found in polycrystalline materials. These boundaries can act as points of weakness and reduce material strength. The casting process is complex and involves specialized molds and cooling techniques. A precisely controlled cooling process ensures that the single crystal structure develops throughout the blade. By achieving a single crystal structure, Rolls-Royce produces blades that can withstand the tremendous forces and temperatures experienced during operation, contributing to the engine's overall efficiency and reliability. Precision machining and assembly. After the casting process, the turbine blades undergo precision machining to meet exacting tolerances. Highly skilled machinists operate state-of-the-art equipment to meticulously shape and finish the blades. Even the slightest deviation from the required dimensions can affect performance, so these craftsmen pay meticulous attention to detail. The assembly process is equally critical, with components like turbine blades, compressors, and combustion chambers assembled with unparalleled precision. Each component must fit together seamlessly, leaving no room for error. Skilled engineers and technicians work diligently to ensure that the engine operates as an integrated, high-performance unit. Balancing for smooth operation. The importance of balancing cannot be overstated. Turbine blades spinning at incredibly high speeds generate tremendous centrifugal forces. To ensure smooth operation and prevent potentially disastrous vibrations, each blade must be balanced to perfection. Balancing involves measuring the weight and center of gravity of each blade and then adding or removing material as needed to achieve perfect balance. This meticulous process demands exceptional attention to detail and craftsmanship. In many cases, specialized equipment and computer-assisted techniques are used to achieve the required precision. The balancing process is repeated until each blade meets the stringent criteria, ensuring the engine runs smoothly and efficiently. Inflation, a secretive step. The document hints at an intriguing step in the turbine blade manufacturing process, inflation. This step remains a closely guarded secret, with Rolls-Royce carefully protecting the proprietary technology. While the specifics are not disclosed, the document suggests that this process imparts additional strength and resilience to the blades, contributing to their exceptional performance under extreme conditions. Rigorous quality control. Throughout the entire manufacturing process, Rolls-Royce adheres to rigorous quality control standards. Advanced inspection techniques, including X-rays, computer inspections, and meticulous visual examinations, are employed to detect any defects or imperfections. Each component is scrutinized to ensure it meets the highest quality standards before being selected for assembly. Global manufacturing. Rolls-Royce's global presence is instrumental in manufacturing jet engines efficiently and effectively. Different components of the engine are produced and assembled at various facilities worldwide. The turbine's purchasing department plays a crucial role in sourcing modules from mainland Europe, ensuring a seamless flow of components to the final assembly location. Testing and validation. Before an engine is deemed flight-worthy, it must undergo exhaustive testing and validation. Rolls-Royce subjects each engine to simulated flight conditions, meticulously analyzing performance under varying loads, temperatures, and pressures. These tests identify any potential issues or inefficiencies, allowing engineers to address them before the engine is cleared for use. Continual advancement and innovation. Rolls-Royce's commitment to innovation is a driving force behind its success in the aerospace industry. The company invests heavily in research and development, constantly pushing the boundaries of jet engine technology. Engineers and scientists strive to make engines more fuel-efficient, environmentally friendly, and powerful, positioning Rolls-Royce as a leading force in the future of aviation. Despite the setbacks and bankruptcy, Rolls-Royce did not give up on their revolutionary engine project. The progress made during the following 12 to 14 months post the bankruptcy was remarkable. They managed to get the engine, named RB211, into service by the end of April 1972. The engine was finally fitted to the Lockheed TriStar, and when the aircraft took flight, the hard work and innovative technology paid off. The RB211 engine became the jewel in Rolls-Royce's crown and set them apart from competitors. Its design was groundbreaking, being the first three-shaft engine, while competitors were still offering two-shaft engines. This new architecture made the engine lighter and more efficient, promising reduced running costs and cheaper airfares for airlines. With the successful launch of the RB211, Rolls-Royce rose from being a small player in the aerospace industry to becoming a global competitor. The engine's success propelled them onto the international stage, and the basic design of the RB211 formed the foundation for the entire family of Trent jumbo jet engines. Today, Rolls-Royce's Trent engines are fitted to half of the world's large passenger jets, and new orders for these engines are worth billions of pounds. The company has become a major player in the global aerospace market. At the heart of this success is the main assembly line at the Derby factory, where all Trent engines are assembled. The assembly line is a well-orchestrated process that takes every build from its first components to a completed engine, adhering to tight schedules and high-quality standards. The assembly process involves fitting together hundreds of precision tool blades, engine control parts, and transmission components by hand. Each bolt is adjusted to a precise torque, ensuring a perfect fit for all modules. Assembling the engine stack is a meticulous process, and the fan, worth as much as a family car, is assembled with expert care and precision. After the assembly, every completed engine is fitted with aerodynamic ducts and moved to the factory's flight test center. Here, the engine is fired up and subjected to rigorous tests simulating the harshest flight conditions. Engineers monitor various parameters, such as vibration, rotation speeds, and temperatures, to ensure the engine performs flawlessly. Additionally, the test center conducts tests on prototypes for new engine designs, guaranteeing the engine's safety before they enter service. The tests include cold start tests, water ingestion tests, and a critical fan blade containment test. Rolls-Royce is committed to safety, and one such test involves the explosive release of a fan blade during maximum takeoff speed to ensure that the fan case effectively contains the blade. Although this test results in the destruction of the engine, it is crucial to confirm the engine's safety under extreme conditions. Rolls-Royce's commitment to innovation, safety, and customer service has secured its position as a leading engine manufacturer in the aviation industry. The data collected from Trent engines in service is continuously transmitted back to the factory, allowing engineers to monitor engine performance and provide comprehensive support packages to airlines. The RB211 engine project, although fraught with challenges, turned out to be a turning point for Rolls-Royce. Their daring and innovative spirit paid off, transforming them from a struggling company into a global aerospace leader. Today, Rolls-Royce's Trent engines continue to power some of the world's most advanced and efficient aircraft, solidifying their position at the forefront of jet engine technology. As the Trent engines continue to power jumbo jets worldwide, Rolls-Royce's commitment to quality and customer satisfaction remains unwavering. The company's reputation relies on monitoring and maintaining thousands of engines 24/7, 365 days a year. The dedicated team of engineers ensures that engines carrying up to 400,000 passengers are safe and reliable, nipping potential problems in the bud before they can disrupt travel plans. The Rolls-Royce Monitoring Center plays a pivotal role in this process, receiving a staggering 1.5 million measurements daily from up to 1,220 engines at a time. The data is analyzed promptly by computers, and any unusual readings trigger automatic alerts to the engineers. Thanks to their experience and expertise, the team can quickly assess and address most issues without causing flight delays or cancellations. On the assembly line, challenges arise, such as the recent holdup of a critical module for a Trent engine. However, the team improvises and continues building other components in the meantime to minimize downtime and costs. Every engine's completion is essential, and any delay in production could lead to substantial financial losses. In Warwickshire, the production team takes pride in crafting the largest fan case ever, destined for a new Airbus. The development of innovative and environmentally friendly technologies like this new fan case ensures Rolls-Royce remains at the forefront of the industry. It also contributes to their success in securing orders, even in a competitive market. The investment in new technologies is complemented by an investment in new talent. Apprenticeships like those offered at the Derby facility play a vital role in keeping manufacturing skills alive and attracting young, passionate engineers to the company. The apprentices receive thorough training over 3 years, ensuring they have the skills and knowledge necessary to excel in their roles. At the Customer Delivery Center, the final step involves meticulous inspections by engine inspectors like Mike Riley. They use advanced tools, such as borescopes, to ensure the engines are in perfect condition before they take to the skies. The responsibility of being the last set of eyes on the engine before it flies is immense, and Rolls-Royce's rigorous quality assurance processes ensure top-notch performance. For the team in Derby, providing the engines for the Boeing Dreamliner's first flight is a moment of immense pride. Their years of hard work and dedication culminate in this historic moment. Orders for the Trent engines start rolling in, reflecting the trust that customers place in Rolls-Royce's cutting-edge technology and commitment to excellence. In Warwickshire, the unveiling of the first fan case for the next engine in the Trent family marks another milestone. It symbolizes the company's drive to innovate and evolve, setting the stage for future success. The project team comes together for a celebratory photo, a testament to their collaborative efforts and passion for engineering excellence. As the Trent engines continue to soar across the skies, the legacy of Rolls-Royce lives on. It is a legacy of innovation, quality, and dedication to crafting some of the world's most reliable and efficient jumbo jet engines. For the employees in Derby and Warwickshire, each day holds new challenges and achievements, driving them to excel and shape the future of aviation. Honolulu International Airport, one of the world's busiest airports, witnessed a remarkable event on a clear morning as aviation enthusiasts and travelers eagerly gathered to witness the pushback and startup of the majestic Boeing 747-8i, one of the largest airplanes still flying the skies. This iconic moment showcased the grandeur and engineering marvel of this legendary aircraft, leaving a lasting impression on all who were fortunate enough to witness it. The Boeing 747-8i, also known as the 747-8 Intercontinental, is a modernized version of the classic Boeing 747, often referred to as the Queen of the Skies. With an extended fuselage and increased seating capacity, this marvel of aviation engineering represents the pinnacle of passenger air travel. Its elegant curves and massive wingspan, spanning over 224 feet, contribute to its awe-inspiring presence on the tarmac. As the morning sun painted the horizon with warm hues, the 747-8i stood tall on the apron, awaiting its departure from the tropical paradise of Honolulu. Ground crew members swarmed around the aircraft, diligently conducting pre-flight checks, ensuring that every system was ready for the journey ahead. The pushback process commenced, slowly easing the massive aircraft away from the terminal. The synchronized dance between the ground tug and the aircraft's pilots showcased the skill and precision required to maneuver such a colossal machine. Spectators lined the perimeter of the airfield, capturing the moment on their cameras and phones, eager to share the marvel of aviation history unfolding before their eyes. As the 747-8i taxied to the runway, The roar of its four powerful engines resonated through the air, an audible testament to its immense power. Despite its vast size, the aircraft's cutting-edge technology and engineering prowess allowed it to glide gracefully along the taxiway. The 747-8I seemed to embody the perfect blend of strength and elegance, a symbol of humanity's ability to conquer the skies. The Boeing 747 has a rich and storied history that has spanned several decades, dating back to its first flight in 1969. Over the years, it has continued to evolve, with the 747-8I representing the latest chapter in this iconic aircraft's legacy. Its enduring popularity is a testament to its versatility, having served as both a commercial airliner and a cargo carrier for various airlines and freight operators worldwide. As the 747-8I positioned itself at the threshold of the runway, its engines roared to life, producing a deafening symphony of power. The aircraft's immense weight and momentum created a palpable sense of anticipation among the spectators. It was a rare moment to witness such a significant event in aviation history. With clearance from air traffic control, the aircraft commenced its takeoff roll. As the runway rapidly disappeared beneath its wheels, the Boeing 747-8I gracefully lifted off into the sky, defying gravity and leaving onlookers in awe. The behemoth gracefully climbed into the heavens, embarking on yet another journey across vast oceans and continents. The sight of the Boeing 747-8I soaring high above the island of Oahu was a poignant reminder of the extraordinary progress made in aviation since the Wright brothers' first flight. This aircraft symbolized not only the remarkable advancements in technology but also the enduring human spirit of exploration and adventure. As the 747-8I disappeared into the horizon, the crowd dispersed, still captivated by the sheer magnificence of what they had witnessed. The pushback and startup of the Boeing 747-8I in Honolulu was an unforgettable event, a celebration of aviation history and an ode to the pioneers who dared to dream of conquering the skies. In an era of rapid technological advancements, the Boeing 747-8I remains a testament to the legacy of aviation's golden age. It continues to inspire awe and admiration, embodying the timeless spirit of exploration and the wonders of human ingenuity, making every encounter with this giant aircraft a truly unforgettable experience.